Good afternoon, everybody. The first thing I want to really focus on is an issue that we've touched on at almost every session, and that's talent. And where does it come from? How do we match it to the needs of the market? Becky and I lead large public universities, research universities in states that are heavy in manufacturing. But the challenge is these CEOs tell us all the time that their workforce needs are going largely unmet. We're not training the right people or enough of the right people. It turns out, though, in our business, as someone mentioned earlier, Sylvia mentioned earlier today, we're much more like mayors than CEOs, and university presidents can't wave a magic wand and say all of a sudden we need X percentage of people studying this, we need Y percentage with that, and we need this many STEM graduates. So the first question I'll ask to Chancellor Blank is what are the approaches you're taking in Wisconsin to try to understand and then to match the skills of your graduates with the workforce needs of the state and the nation?
Yeah, thank you. So let me say two things. The first is a little more basic than that question, which is we do need more STEM workers, particularly. And the first answer to that has to be bringing a broader and more diverse population into the university and engaging them in the STEM fields. And that often requires a degree of advising and cultural competency in that advising, particularly in the introductory classes that are the gateway classes for STEM of math and chemistry and things that particularly first-generation students from more disadvantaged backgrounds, students who have not gone to some of the same high schools, just find it a little harder to get into those courses and to engage in them in the same way. And so we've really done a number of things to expand our advisory capacities, particularly aimed at groups that are historically not big in the STEM fields. And both given training to all of our advisors, but explicitly diversified our advising staff in ways that addresses that. So, bringing more people in. And I would make a comment that the issue here is, by and large, not getting people into college. 90% of those who graduate from high school start some form of higher education. The issue is completion. Of those who start, only 60% finish if they go to a 4-year school, only 30% finish if they go to a 2-year school. So what we've got to do is up completion and do more to encourage people to consider some of the skill areas where manufacturing is particularly interested in. Now, let me segue from that into saying, well, what do you do specifically to be in touch with manufacturers? And, of course, there's always a long answer to that, but the answer has to be partnership, right? That we are in touch with a good number of the, obviously the manufacturers in the region hire heavily from both of our schools, and we really try to create not just partnerships at the point our students become a senior and are looking around, but partnerships from the very beginning on. And this is particularly important for manufacturing companies that often don't have retail presence, so that our students coming in may not have heard of them. They may not have heard of Oshkosh Truck. They may not have heard of Johnson Controls, companies that have very large presence in the state of Wisconsin, but don't have a presence to an 18-year-old who only knows the consumer companies. So we try to bring them in from the very beginning, involve them in classes, encourage them to sponsor competitions. Obviously, they work very hard on telling every student, if possible, they've got to do some internship work, placing them in regional companies of that sort. The companies have to be a partner with that and be very proactive on our campus. They can't just show up when hiring comes around.
Yep.
Yeah.
So we tend to focus a lot on STEM. STEM is the rage, and obviously there's a huge need forecasted in tens of millions of STEM educated workers. But how many folks here in the room were liberal arts majors in college? Mm-hmm. Good. Me too. Mm-hmm. So I think we tend to forget the things you learn as a liberal arts student that are qualities of leadership, qualities of being a good employee, qualities of having personal agency and leadership abilities. So I wouldn't want us to forget the breadth of opportunity for liberal arts majors as well.
I should note that one of the stories I love to tell is that our philosophy department, which is very highly ranked, has become extremely popular, huge increase in majors. The reason is the high share of those majors are going out to Californias and working for the Googles and the Amazons and the tech companies, because what you learn in philosophy in terms of how to think and how to follow logical sequences are very important for the product development of those companies. It's a wonderful example where a major that many people think must be utterly irrelevant to the business world is actually very central.
That's great. So Bill, you head up one of our great national labs, Livermore National Labs. And to my surprise, a topic that has barely been touched on here, and a phrase that I think I've only heard once, is climate change. Now, the topic here for today, though, is turbocharging the economy. And turbocharging, for me, conjures up energy. And Livermore Labs is at the forefront of energy research. But Bill, how do we develop, and how is Livermore contributing to the development of energy efficiency, renewable forms of energy, new modes of transmission, and regulate control of energy, with perhaps the greatest scientific and ecological challenge that our generation's ever going to face, looming in the not too distant future?
Well, so first of all, let me just note with respect to the workforce question.
Yeah.
So the report you kind of referred to, the Accelerate report, which is about turbocharging the economy with respect to energy and manufacturing, actually makes a number of very strong recommendations with respect to workforce development, and in particular partnerships and collaboration in that direction. So I'd urge people to take a look at those. I think they're really quite excellent. So I just to sort of work into the topic you brought up, I was struck by in particular the TED talk we had today about the OLLI, the 3D manufactured autonomous bus, and in particular the way that opened up, and it struck me as an important way to start to think about this. But I think I want to take it in a slightly different direction. So as we know, GM has recently closed a set of assembly plants in the U.S. and Canada, and although I'm not even an amateur in understanding the kind of forces that motivate this, my understanding is it has something to do with the fact that GM loses money on the kinds of cars that are produced in these plants, and consumers are moving towards models that, because of gas prices being lower, moving towards trucks and SUVs. Long term, I understand the GM might actually be able to convert these plants into making the more profitable models, but that'll take capital investment and it'll take time. So the question that it raises for me is, what if it didn't take time or that kind of capital investment? What if rather than cutting and stamping the big pieces of metal and other materials, which means having to swap out large pieces of specialized machinery in these plants, and maybe even re-educating the people who work there. What if you can in fact produce all the parts using 3D printing? And we saw an example of that early today, but not just to produce this particular thing, but if you could actually, rather than change all the machines that were making the parts for a car, the 50,000 parts, if you will, but if in fact you could just push out a new program over the internet in order to make the change that you wanted to make. You wouldn't be, presumably, it would be possible not to be in the position of having to deal with the kind of economic dislocation that the manufacturing sector has to deal with now. Of course, I know that machines these days are highly digital, and but it seems to me that what we see going on in manufacturing is not taking advantage of the degree of nimbleness and customization that's potentially possible if innovation in this area of advanced manufacturing can continue to accelerate. And that's really the message that I want to provide, is that there are ways to accelerate it, and there are directions that can have a real economic impact for the U.S. The national labs are helping, I think, to forge this innovation. You heard about that in the case of the Ollie vehicle, which was a follow-on to the 3D printing of an entire automobile by Oak Ridge National Laboratory. At my lab, Lawrence Livermore, we've been able to directly print metal parts, carbon fiber composites, and optical quality glass. We're starting to get to the point where we can actually print all of the things that might go into things like vehicles. The U.S., I believe, is and can continue to be and can be more of an innovator in these technologies, and is well positioned to lead in the application to this new frontier in manufacturing, especially given the boost that we've experienced from ample domestic energy generation and low prices. This is at low energy prices. This is a situation where the stars are in some sense aligning for success for us. You asked about climate. Another area in which innovation in manufacturing has important implications for energy and climate has to do with ways in which we process, utilize, and recycle carbon using advanced manufacturing processes. And again, here we're finding that 3D printing and advanced manufacturing can be an important technology enabler in this landscape, in the fact that it can allow more complicated products to be built in important ways that can't be done with conventional manufacturing. And we've found that additive manufacturing, in fact, can create new kinds of chemical reactors in which you combine things like carbon dioxide with the catalysts in ways that optimize flow and surface area, for example, in ways that you couldn't do with couldn't build these kinds of reactors with other kinds of manufacturing.
I'm going to try to move on and let Nick get a word in.
I'm sorry.
That's okay. Hi, Nick.
Hello. I thought your PhD was in medicine, not liberal arts.
Actually, I was a Princeton undergrad. We're all liberal arts majors.
I see.
So, but Nick, you're a long-serving CEO at Snap-on, a company very well known and strongly branded in parts of our economy, as you mentioned. But one of the big challenges that we confront, that we spoke about at this meeting, has to do with collaboration between the many different sectors that are going to be necessary for our continued competitive success. So how do you see ways to optimize our full potential by provoking or promoting collaboration between policymakers and business, universities, national labs, labor? We come from such different cultures and almost speak different languages and hang out with different people. How do we all get on the same page to promote effective economic growth?
That's a mouthful, but look, it seems to me as though it has to do with what's important right now and what's compelling. I can tell you as a manufacturer, what's compelling to us, the most important thing is skilled labor, the people. Why we can't do it is we're confused about the horizon and we're confused about the model for the future, I believe. I'm just a tool maker, I'm up here with these PhDs, theoretical physics and so on. You're probably sitting in the audience thinking this is the council's Rube outreach program, put a guy like me up here. But look, we do business in 130 countries, but 80% of what we sell here in America is made right here. We've never moved a product overseas, and 50% of a hand tool is labor. Not many manufacturers can say much about that. But don't get me wrong, we believe in what the council has done. This Accelerate document is brilliant, and the Honorable and Eminent Deborah Wynn Smith and her staff have done a great job. I just might disagree with the priorities or the implied priorities. We think number one is skilled labor. You could ask the National Association of Manufacturers about this. You see, here's the thing, is we talk today a lot about game-changing innovations, singularities. But manufacturers know that when you're thinking about tomorrow, singularities are few, actually. And the time constants in which they approach the now are uncertain. So when we think about the future, we realize we want to go to tomorrow, but we realize most of all that the path to tomorrow leads right through today. And today, we need skilled workers. 500,000 jobs in American and manufacturing are going unfilled. 2 million by the year 2025, according to the National Association of Manufacturers. And it's different than other sectors, because though they are competing with other jurisdictions to be the amplifiers of ideas for those jobs, not like construction or auto repair, which have to be done here. You see, that's the whole thing about this. And part of the difficulty of focusing on this and getting together is, one, that timeline, always looking for the home run, the delivery. This is going to transform us. Well, actually, my world is day by day, even as I go to tomorrow. And then secondly, there's a kind of clash of future visions. The first vision is articulated by a guy named Yuval Noah Harari. He wrote Homo Deus, the brief history of tomorrow, and he was declared by the New York Times to be the darling of tech CEOs in Silicon Valley. And he talks about a dystopian future where a few people are brilliant and create ideas which transform society and create the value that allows and supports a teeming group of people he calls the useless class. The useless class. And you see, those people, they were makers and fixers who transformed us. Then there's an alternate view of the future which says we can't just talk about ideas and innovation and transformations. We have to get those, but we also have to think about how we're going to implement them with our people, because that's always been the American strength. That's always been the American strength. The idea, the makers and the fixers, millions strong, being the amplifiers for ideas. And that means upskilling the American workforce, giving them not the skills of tomorrow, but the skills of today. I need people who will do 3D modeling. I need people who do high compression welding. I need people who will do CNC programming and have the scope to go forward, but I need them now. This is what manufacturing needs to explode. So if you ask me as how to bring people together, I say it is focusing on that. It is understanding that, yes, we have to focus on the ideas, the brilliance of the few, but we have to understand that America cannot be America without the efforts of the many, the makers and the fixers applying skills that are better than everybody else. 2/3 of American manufacturers says the number one characteristic for locating a factory is skilled workforce. So the idea is to come together around that. I think business and education and labor can come together about that. But we can't be distracted looking for the home run. We can't drive ourselves to that dystopian future that would say these people are going to become the useless class. We have to recognize the value of the people who are Americans, the makers and the fixers, and that will deliver us from evil.
Wow.
Snap on.
Snap on. Becky, as we're running out of time, how should research universities be engaged in focusing on the needs of industry? So how can you target or incentivize faculty-driven, graduate student-driven research onto areas that are aligning with the emerging needs of the economy?
Well, so that is obviously research partnerships where you set things up in such a way that, and the way this usually works best is, it works best, I must say, with the big companies often, where there is a close relationship between some individuals in the company and a lab or a project or a group of faculty, and they basically sort of are scanning what the faculty are doing. They're often in conversations. It shapes some of the interests, and you find those points of common interest. As you well know, you can't direct faculty to work on something that they aren't interested in, but you set this up because there's a bunch of common interests between this industry, this company, that lab, those people. And the industry sort of gets first look at all of this, and it often then pulls this in and does the very applied work to turn it into a product or something that they can use. But that type of partnership is by far the best way, I think the most proven way to create those sorts of conversations and transfer of information.
Yep. I think, I'd like to make the last point is one of the things I heard earlier in the meeting today really resonated with me, and it was the anecdote about Al Gore and the internet. Mm-hmm. And the idea that you could have a bunch of discovery scientists working at a university getting very excited about something they've discovered, something they've developed, but not really looking at things and having a mindset that helps them appreciate what the potential usefulness is. So one of the things I think we need to do more of as a society is find more ways to have industrial leaders that are used to identifying and developing products basically come and hang out at universities and see what we're up to. Because I bet you a lot of the things that we don't recognize as potential valuable intellectual property in the eyes of an experienced industrialist who's used to identifying and developing products might prove to have way more value than we think. So that's my 2 cents of contribution. Thank you very much to the panelists, and we're off.